All right, let's talk about uniform motion. Physicists, scientists, we call the study of motion, that's better, kinematics. Oops. Kinematics. And in kinematics, because I really like to talk about units, we use the three of the base units of the SI, System International, or metric system. We use the meter for distance. We use the second for time, and we use the kilogram for mass. And all the others we can derive from them, like force is measured in newtons, and they're a combination of meters, seconds, and kilograms. So let's play a little game that you've probably played before when you were young, I Spy. And if I was to say, I spy an object that's 1 meter from you, your head would spin around looking for things that are 1 meter from you, and you'd start to guess. And if you couldn't figure it out, I would say that it's 1 meter from you on the ground. Yes? And your head would immediately look down at the ground, and you'd trace that circle out around 1 meter from you. And then if I said that it's 1 meter from you, it's on the ground, and it is on your right. Your head would spin around to the right, and you would hopefully identify what that object was. And so in each case, the clues are giving you more information about direction. And direction is really important in physics. In physics, there are 2 types of numbers in physics, scalars and vectors. Scalars have a magnitude, which means a number, yes, and they have a unit. Vectors have a magnitude, they have a unit, but they also have a direction. Okay? Big difference between these two, and we have to keep them straight. An example of a scalar is distance, and we in physics give that the symbol d, little d. Another example of a vector that's related to distance is your displacement, and we give that a d with a little arrow on top because displacement needs a direction associated with it. And now, how are they different? So let's talk about how these two things are different, looking at 2 examples. We have a bee, and he flies north 3 meters and then east 4 meters. How far has he flown? What is the distance he has flown? That's 7 meters. 3 plus 4. But how far is he from his original location, his displacement from where he started? He is that far away, and this is a 3, 4, 5 triangle, so his displacement would be 5 meters, and I'd need this angle right here, and I think that it's 42 degrees. I think that it's north 42 degrees east, but don't quote me on that. Very different answers here, distance, displacement. Another tricky one that you might encounter is a circular path. If you start at one part of a circular track and you run all the way around, and if it's like an Olympic-sized track, you would have gone 400 meters. That's how far you would have run. However, what is your displacement when you cross the finish line here? Your displacement would be 0 meters, because the only thing that matters, with displacement, the path taken does not matter. Okay? Only the start and finish matter. Okay? But with this distance, the path taken does matter. Okay? So for example, if I told you in the classroom, here's our classroom, to get up out of your desk and go and sit in this desk, you could go this way, this way, this way, this way, this way. If there's a door here, you could go out the door and around and back and through this door. All of those paths would probably have a different distance taken, but your displacement would always be the same. It doesn't matter how you get there with displacement. The only thing that matters is where you start and where you end. Okay? Distance and displacement, they're used to calculate two other quantities. Speed is distance over time, and its close cousin is velocity, which is displacement over time. And in terms of formulas and using letters, we would say that V is d over t, and down here we would say that V with a little arrow is d over t, remembering that the arrow means it's a vector quantity. And so these are two formulas and four values, distance, displacement, speed, velocity, that we'll be using in this class all over the place.